Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Glaciers, vast rivers of ice, hold a profound beauty and power. They are remnants of past climates, silent storytellers of Earth's history. These frozen giants, some older than human civilization, captivate our imagination. Their sheer scale and grandeur remind us of nature's awe-inspiring forces. From the towering peaks of the Himalayas to the polar expanses of Antarctica, glaciers shape our planet. They carve mountains, sculpt valleys, and influence ocean currents. These frozen reservoirs hold within their icy grip secrets of Earth's past and present. They are vital indicators of our planet's health. Their pristine beauty conceals a complex dance of ice, water, and time. Understanding glaciers is not just about appreciating their beauty, it's about comprehending the delicate balance of our planet's systems. Let's embark on a journey to unveil the mysteries of these frozen titans. We will explore their formation, delve into their diverse forms, and discover why their fate is inextricably linked to our own. Glaciers, despite their immense size, begin with something small: snowflakes. High in the mountains where temperatures rarely rise above freezing, snow accumulates year after year. As layers of snow pile up, the weight compresses the lower layers. This compression transforms the fluffy snow into denser firn, an intermediate stage between snow and glacial ice. Air pockets within the firn become smaller, eventually squeezing out most of the air. Over time, the firn compacts further, transforming into glacial ice, denser and more translucent than its snowy precursor. This process of transformation from snowflake to glacial ice can take decades or even centuries. The speed of glacier formation depends on various factors, including snowfall, temperature, and the slope of the terrain. The weight of the accumulating ice forces the glacier to flow slowly downhill, like a river of ice. This constant movement, combined with the freezing and thawing of meltwater, shapes the glacier and carves the landscape beneath it. Among the most visually stunning types of glaciers are valley glaciers, often referred to as alpine glaciers. These rivers of ice snake their way down mountain valleys, carving and shaping the landscape as they flow. They originate high in the mountains, where snow accumulates in bowl-shaped depressions called cirques. As the glacier grows, it spills out of the cirque and flows down pre-existing valleys, often following the path of ancient rivers. The glacier's immense weight and erosive power deepen and widen the valley, creating dramatic U-shaped valleys. These valleys, with their steep sides and flat bottoms, are testaments to the glacier's relentless force. Valley glaciers can range in size from a few kilometers to hundreds of kilometers long. They are constantly moving, albeit very slowly, typically at a rate of a few centimeters to a few meters per day. As these icy rivers flow, they transport rocks, soil, and other debris, which they have eroded from the surrounding landscape. This debris, known as glacial till, is deposited at the glacier's edges, forming distinctive landforms like moraines and eskers. Unlike valley glaciers, which are confined to valleys, ice caps and ice fields spread out over large areas, covering mountain peaks and plateaus. An ice cap, typically smaller than an ice field, covers a relatively small area, less than 50,000 square kilometers. Ice fields, on the other hand, can cover vast expanses, blanketing entire mountain ranges. These massive sheets of ice, often thousands of meters thick, exert immense pressure on the land beneath them. They depress the Earth's crust, creating depressions that can persist long after the ice has melted. Ice caps and ice fields, like their valley glacier counterparts, also contribute to erosion and deposition. They grind down the underlying bedrock, carving out valleys and lakes. As they melt, they deposit glacial till, forming moraines and other glacial landforms. Ice caps and ice fields play a crucial role in regulating regional climates. Their bright white surfaces reflect sunlight back into space, helping to cool the planet. The largest type of glacier, ice sheets, are continental-scale masses of ice that cover vast areas of land. These colossal ice sheets, found only in Antarctica and Greenland today, are the ultimate architects of landscapes, shaping continents over millennia. They contain the vast majority of Earth's freshwater ice. The Antarctic ice sheet, the largest ice sheet on Earth, covers an area larger than the United States and Mexico combined. It is so massive that it influences weather patterns across the globe. The Greenland ice sheet, although smaller than its Antarctic counterpart, is no less impressive. It covers most of Greenland and contains enough ice to raise global sea levels by several meters if it were to melt entirely. Ice sheets, due to their immense size and weight, exert enormous pressure on the Earth's crust, causing it to sag. This isostatic depression can alter the shape of continents and affect the flow of rivers and ocean currents. As ice sheets grow and shrink over time, they leave behind a legacy of glacial landforms, shaping the landscapes we see today. Piedmont glaciers form when valley glaciers confined to their mountain valleys spill out onto flatter terrain. Like pancake batter spreading on a griddle, the glacier spreads out laterally, forming a lobe-shaped mass of ice. These glaciers, often found at the base of mountain ranges, are characterized by their gentle slopes and expansive surfaces. They act as buffers, slowing the flow of ice from the valley glaciers above. Piedmont glaciers, though not as confined as valley glaciers, still exert considerable erosive power. They grind down the underlying bedrock, carving out valleys and lakes. Their meltwater also contributes to the formation of braided rivers, characterized by multiple channels that weave across a wide, sediment-filled floodplain. These glaciers, with their unique morphology and dynamic nature, add to the diversity and splendor of Earth's glacial landscapes. Tidewater glaciers, as their name suggests, are glaciers that terminate in the ocean. These glaciers, found in polar and subpolar regions, play a crucial role in the global climate system. They act as a link between the cryosphere, the frozen part of the Earth's system, and the hydrosphere, the Earth's water. As tidewater glaciers flow into the ocean, they calve, a process in which large chunks of ice break off and float away as icebergs. This calving process is a spectacular sight with thunderous roars and towering waves. It is also a vital process as it contributes to the freshwater balance of the oceans. The freshwater released by melting glaciers and icebergs influences ocean currents, affecting global climate patterns. Tidewater glaciers, with their dynamic interactions with the ocean, are sentinels of climate change, their fluctuations providing valuable insights into the health of our planet. Glaciers, far from being static features of the landscape, are dynamic systems that play a vital role in shaping our planet. They are not only indicators of climate change, but also active players in regulating Earth's climate system. Their bright surfaces reflect sunlight back into space, helping to cool the planet. They store vast amounts of fresh water which, when released gradually through melting, sustains rivers and ecosystems. Glacial meltwater is a lifeline for many communities, providing water for drinking, irrigation, and hydropower. Glaciers also shape the landscapes we see today. They carve mountains, sculpt valleys, and deposit fertile soils, influencing the distribution of plants and animals. Understanding glaciers is not just about appreciating their beauty, it's about recognizing their fundamental importance to the health of our planet and the well-being of humanity. Glaciers, these frozen titans of time, are facing an unprecedented threat: climate change. As global temperatures rise, glaciers around the world are retreating at an alarming rate. The consequences of this melting are far-reaching, from rising sea levels to water scarcity in glacier-fed regions. Protecting glaciers is not just about preserving scenic beauty, it's about safeguarding the planet's life support systems. We must act now to mitigate climate change by reducing greenhouse gas emissions. Supporting sustainable practices, promoting renewable energy, and advocating for environmental policies are crucial steps. Educating ourselves and future generations about the importance of glaciers and the impacts of climate change is paramount. Let us be stewards of our planet, working together to protect these frozen wonders for generations to come. Their fate is intertwined with our own, and their preservation is a testament to our commitment to a sustainable future. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.